All right, my name is Mr. Janssens, and this is Precalc 12 at Surrey Christian. This is Unit 1, Lesson 1. The unit is called Functions. The lesson is called What the Function? And if you can name the guy in the background, 10 points for your house cup. I'll tell you who he is at the end of the video. What we're going to learn in this video: what is a function? Where else would I have heard of functions? What does a function mean specifically in math? And how do I know if a relation or a relationship is a function? So where have you heard functions before? Well, things that are functional, like a bridge serves a function, right? It connects one piece of land to another. You can go to a social function, um, like a party serves a function of, hanging out with friends and stuff. Definitely pre-COVID video. Um, a car serves a function, and not only does a car serve a function, it has a purpose, but all the pieces of a car serve a function to making the car work as well. So how about in math? In math, we talk about functions. We refer to, and this is going to be our formal definition, it refers to a relation that assigns an element from one set, let's say set X, to exactly one element in another set, in this case set Y. And so a function means that each element in this first set has only one arrow coming out of it. So we can say all elements, the elements being 1, 2, 3, and 4 in this case, all the elements of X combined represent a group of inputs called the domain. Over here in group Y, we have elements A, B, C, and D, and these elements combined represent the group of outputs called the range. So a function maps all the domain elements to all the range elements. Now, given the function f of x equals 5x plus 1, f is the name of the function. So before, like in algebra, letters stand for some numerical value. When we talk about functions, letters not only can stand for a numerical value, they can also stand for a function value. So in this case, f is a function, and x is going to be a variable, some numerical value. And so this function f will assign each element in x, in this subset, to some element in the y set. So these x values are all called inputs. We can take these x values and put them into our equation. So f of -1, f of 2, f of 5, f of 8. And if we do that, we do a calculation. It gives us the y value assignment. So f of 1 is equal to -4. So over here in our domain, -1 gets an arrow that goes to -4 in our range. And similarly, f of 2 moves to 11, f of 5 moves to 26, f of 8 moves to 41. So 2 has an arrow to 11, 8 has an arrow to 41, and 5 has an arrow to 26. So this is a mapping of what a function looks like. Again, each element in the domain has only one arrow coming out of it. Let's look at some examples. All right, here's 3 examples. The first example is an example that is not a function. The other 2 examples are functions. The first one is not a function, so I see in order for it to be a function, like I said, each element can only have one arrow coming out of it. And so because 2 maps to both B and C, we don't have a clear definition of what the assignment is. Does it go to B? Does it go to C? We can call it a relation, but we can't call it a function. So if we look at the second example, 1, 2, 3, 4, they each have one arrow coming out of it. So it's very clear what the outputs are for each of those elements. So we have a function here. You may notice that 2 and 3 both map to B, and nothing maps to C. Oh, poor C. It's okay. He doesn't need anyone. That's okay. This is still a function because each element in the domain has only one arrow coming out of it. Still a function. The third example is also a function. Again, each element in the domain has only one arrow coming out of it, mapping to exactly one or only one output. So here's another example. And in this case, unlike the previous example, our representation is now a set of ordered pairs. And so this set of ordered pairs is a list of x and y values, and it tells us the x values map to the adjacent y value. So 4 in our domain maps to 3 in our range. So like 4 goes to 3. 5, 8 tells us that 5 maps to 8. 2, -1 tells us that 2 maps to -1, and 0, 2 tells us that 0 maps to 2. So this first example, each input or each element in the domain has only one arrow coming out of it. So this is a function. Now, the second example is not a function. If you can visualize the mapping of this set of ordered pairs, and specifically if we look at just the value, the element 2 in the domain, the first ordered pair tells us that 2 maps to the output 3, but the third ordered pair tells us that 2 maps to -1. So if I put 2 into the relation, does it map to 3 or does it map to -1? It's not clearly defined, so we're going to say this set does not represent a function. Now, the fourth one, this is a function. We see each x value only once, so we know that they're mapping each to only one y value. The third one is also a function. Now, same question, but now from a graphical representation. Determine if each graph represents a function. So if we look at this thing and we look at any x value on this graph, so let's pick x equals 6. At x equals 6, we see one part of the line at x equals 6, and we can map that over to the y value. So 6 would map to about 0. If we pick 10, I'm going to estimate here, it looks a little below 1, but I'm going to say if we pick 10, 10 will map to somewhere about maybe 1/2. If we pick 2, we're going to map somewhere to about -1/2. Let's talk about -2. So this happens to be a cube root function, and so if you look at -2, it looks like we've got a vertical line right here. Because I know it's a cube root function, I know this line is not vertical. There is an ever so slight slope to this little interval of the line right here. If it was a completely vertical line, -2 could map to any point on that vertical line, which would make this not a function. However, like I said, this is a cube root function. I know this is going to continue to be slightly sloped, even though it looks straight. It does have a slant to it. So if you pick any decimal value close to -2, you're going to get a unique y value, albeit another decimal answer. And so because this is a slanted line and not a straight vertical line, we're going to say that each x value maps to only one y value. Therefore, it's a function. So now this example, we've got kind of a hyperbolic situation here. Is this a function? No. And I can clearly see it's not a function if I examine the x value of -2. At -2, if I go above the x-axis, I see that this graph tells me that it maps to the value of +4. So -2 maps to 4. However, if I go below the x value, the x-axis, I see -2 should also map to -4. So -2 maps to +4 and -4. So right there I know because of this value, and we could pick other values just like it that'll give us multiple mappings as well. But just because of this value right here, we already know that this graph does not represent a function. So another example of a graph, if we look at each x value will map to exactly one y value. If I pick 6, it's going to be about 3, or so 6 maps to 3, just below 3, maybe 2.9. 8 maps to just above 3, maybe 3.1. 2 maps to 2. 0 maps to 1.5. -2 maps to 0. And any point below -2 doesn't map to anything. So if we drew that line, if we drew that map, there would be no elements in the domain that have more than one arrow coming out of them. So we know that this would be a function. So let's talk about the vertical line test. The vertical line test is our friend. It's a really easy way to tell if a graph is a function or not. Here's how the vertical line test works. If you can draw a vertical line anywhere on the graph that hits the function more than once, then it is not a function. Conversely, if you cannot draw a line that hits the graph more than once, then it is a function. So the first example, no matter where I draw a vertical line, I'm not going to hit this graph more than once. This is a function. The second example, there are multiple spots where I can draw a vertical line and hit this graph twice. So for that reason, this is not a function. Third example, like the first, there's nowhere where I can hit the graph twice. It's okay if I don't hit the graph, I just can't hit it twice. So this third example is a function. Takeaways. So we talked about how to identify if something is if some kind of relationship is a function, and we looked at that for multiple different representations. We looked at mappings, we looked at sets of ordered pairs, and we looked at graphs. We now understand the domain is a set of inputs for a function, and the range is a set of outputs for a function. And we also learned that the vertical line test is our friend, and it will help us a lot.